This morning the theme is sort of tools that we're building, tools that customers have been using, and then this afternoon we have the educational section with the prize winner ceremony and so on. And I'm going to help you limber up. This is actually 3 10-minute talks on some small tools that we're making available, interfaces to 3 products, external products. Numerical Algorithms Group, numerical libraries, the R statistical framework, and Q, which is a high-performance database. Right, so these are really 3 completely independent tools that I'm going to try and spend roughly 10 minutes on each. How many people here have heard of R? Everybody, right. That's not surprising, because what I was going to say is in the last few years, it's rapidly risen to become, by far, I think, the most popular tool for doing statistics and data mining and so on outside the APL community. And I think it's very important to be able to easily access that from APL, and that's what we've provided an interface that you can do with. So it's a free programming language for statistical computing. Some people call it a platform. If you use something called S in the past, this is really an open source version of that. And it's very, very widely used. There are users all over the place. And in addition, actually, to the statistical calculations, so this is just a web page for the Birmingham Academic, University in Birmingham, with examples of graphics that they've done, statistics they've done in R. There is now a Birmingham, UK R user group, if you're from around there. And the features of what we're calling R Connect, the interface from APL to R, is that it encapsulates the R environment as an object that you have in your workspace, and you can then call functions in R more or less as if they were functions in your own workspace. We've also done some work to make sure that the most common R objects, R has tables and time series and a bunch of data types that it operates on, that those are nicely translated into APL arrays that you can easily use. And let's have a demo of that. Okay, so there's a workspace that you need to load. You need to make an instance of the R object. Is that big enough for everybody at the back as well? Yep. Move the bottom of the screen up a little bit. Okay, there's a little command that I'm skipping over here. That's if I'd been using the 32-bit version of R here, because I have a 64-bit operating system, there's a little initial call I would have to make to tell it where to find the R drivers, because it would go and look for the 64-bit ones. You have to initialize the interface, and then you can start executing R expressions. Doesn't that look useful? I think the people who built R also did look a bit at APL, although the syntax isn't quite as nice. So this is my favorite APL expression, the one that got me hooked on APL, adding 2 vectors together. And you see there's a little bit more syntax required to catenate together. The C function is catenate, I think, to construct vectors. You can make matrices, though that wasn't exactly what we expected, was it? And R has this wonderful rich syntax to allow you to specify how things work. So we can get the matrix that we want. But of course, doing that kind of thing isn't what you're going to be looking for in R. It's more things like it has, of course, all kinds of statistical functions. So this is give me a 10-item vector, normally distributed. We allow you to hook straight into the help system. So I said help R norm, and we can then see the online help for the R norm function. And we can find out that we could, in fact, have 1,000 numbers with an average of 100 and a standard deviation of 1. Get that back into APL as a 1,000-element vector. Looks like this. There's a function to allow you to transfer variables back into R. So this is r.p is for put. So create a variable in the R space called norm R containing the data in this variable called norm APL. and an r.g to get it back, and we can see that those two are indeed identical, which is what we were hoping for. And then we can start using statistical functions in R. I'm not going to go into those in great detail. There's a very nice, if you want to know more about R, then there's a very nice introduction by Simon Marsden of micro-APL in Vector. If you go and search in Vector, I think it's 3-4 years since he did that. APLX also has an interface to R. And one of the things that we've done to make this really easy to use from APL is in this expression that you execute in R, if you put an omega in the expression, that then is a parameter placeholder. So this variable in my workspace, norm APL, was substituted into that expression, and we called the R summary function on this APL variable directly. So R has a very loosely typed object system. This is something called a time series. And what we've tried to do when we bring one of these back into APL, we use this famous quad df display form to set the display form of the object that's created in APL so that it tells us something about the R object. So this text displayed here tells us it's an R time series, 468 observations, and something about the frequency and the start and end. So here we're using the summary function back in R to get a summary of this data. We can retrieve that variable into APL. Okay, that was a bit... There's also an r.f. So if you want to know how R would format this variable, rather than seeing how we format it, you can call r.f, and then that gets the R environment to format it as it would have been displayed if you were in an R session and displayed it there. But in the APL workspace, we have this thing which displays like that, and it has a small number of properties. We can ask what its attributes are. It has two, a class which is TS, and a TSP, the time series parameters properties, which tell us the start and end and the frequency. You can also index into these attributes using this keyed index mechanism. And you can extract the value, which I suppose is what you would most often be looking for. R also has graphics, and so here's some data, some sines and cosines and square roots. What's this going to look like? Well, we're going to call the R perspective chart. We're going to pass 3 parameters. We just use omega for all of them, and the variables have to appear in that order. Various chart parameters to do with 3-dimensional viewing, labels, etc. And then we're passing actually x twice here, because the x, we're using the same values for x and y, and then z that we computed, or z, and we can see a Mexican hat. Isn't that cute? So that's the R demo. The two other, so why are we doing this? Well, the most important one is, we're hoping to attract a bunch of new users into APL. And many of the young people coming to APL will have existing skills in R, well, young or old. And we really want to avoid this sort of cold turkey situation where if you go to APL, you can't tap into your existing skills. Also for APL programmers, there really is a state-of-the-art statistics, sort of the most trusted statistics and graphics library at the moment. And one thing that Professor Skomorokov at Obninsk, who helped us with this, pointed out that even if you decide not to use R in your application for licensing reasons, it's open source and it has a license form where you can't actually ship R with your product. You would have to rely on the customer having installed R already. What you can do is you can write your own statistical routines in APL, and then you can use R to verify that your calculations are correct. So you can use it as a testing tool for the statistics that you decide to embed in your product. So this tool was actually written by Ronald Chan, who was the winner of the first Dyalog programming contest back in, 2009? About half a year later, he decided to swap 3 months of New Zealand summer for 3 months of English winter. Spent 3 months as an intern at Dyalog, and in addition to helping us with the matrix inverse and stuff like that on DECFs, which is what we were working on at the time, he one weekend, over Christmas, he came to see us in Denmark. And one afternoon he learned how to do cross-country skiing, and then he was bored and he spent the rest of the day implementing this interface. And we've been sitting on it for some years, and it's really only with the arrival now of Fiona, the full-time technical writer, such a good thing, that we now feel we have the capacity to document this and officially support it. So the goal is that after Christmas, with a delay of only 4 years, we will now make this officially available and supported. But note that we cannot distribute R, and neither can you. You'll have to get it from somewhere else. Which brings us to the next tool that we're interfacing to, NAG, Numerical Algorithms Group, is an organization I think based in Oxford, is still their headquarters. A bunch of mathematicians who got together and decided to build very high quality numerical algorithms. They now have over 1,700 functions. And on their webpage they claim that it's the largest collection of reliable and supported numerical algorithms commercially available. And there's going to be a lot of overlap with what R can do and what NAG can do. It's not one-to-one at all. NAG does all sorts of optimization stuff and so on. But the advantage is that although it's not free, you can get a license from them and you can bundle it into your product and you can ship it if you want to use these libraries. And I'm just going to leave this up for 30 seconds and say nothing. I can't do that actually, but didn't work. 10 seconds. There's another page. Go to their web page. There's a humongous amount of stuff. And in fact, that is a bit of a problem because each one of these is either a C library or a Fortran library call. And it's a quad NA call. What we have done that's special in version 14 is Jeff has extended quad NA so that libraries like NAG can call back into APL, because a lot of what's interesting about the NAG libraries is optimization routines, which are doing interpolations and so on, and they need to call back to compute some kind of value. And you want to be able to write that function in APL. So the extension in version 14 is allowing callbacks. But for each one of these NAG functions, somebody's going to have to build a cover function for quad NA. Now, we're talking to the people at NAG, and they do have an XML description of all 1,700 functions. And we think we can build a tool, that's what we're going to be looking at in the next few months, that will automatically generate a simple cover function for any one of these NAG functions. But then you'll probably need to do a little bit of tweaking. As in what we're hoping is, people will go out, they'll use the most interesting functions and they'll tweak the auto-generated ones, and then we'll collect them and we can all work together to establish an open source library of cover functions for NAG. So let's see if I can give you a quick demo of that. So I'm going to use one of their functions that makes a two-dimensional spline. BoxOn, new version 14 feature, which allows me which turns on boxing by default in the output. So here's a two-dimensional array of data. We have some X values, some Y values, and the Z value at that point. Let's just use R to visualize that using the 3D plot. So we have a surface that looks like this. We only have a small number of points. And what the 2D spline allows us to do, I'll trace through that. So this is just to show you what this kind of cover function looks like. the ride is so much better at docking things back again when you've unintentionally undocked them. So we have these three parameters, and then the Fortran library wants some count. What is the length of dimensions? We have to gather that, transpose the array into the Fortran column-oriented, compute a few other parameters, and then finally, there isn't enough room to. Finally, we call the NAG function, or we have a small cover on top of that. So we're creating the quadern A parameters. It's a variable that looks like this. This is an integer, 8-byte float, etc. arrays. And that we think we can pretty much generate these two functions I've traced through now. But they won't look pretty, and it'll probably be useful if somebody, for each one that's really useful, somebody does a little bit of work to tweak the functions and make them slightly prettier. Okay, so we did the interpolation of that data, and we got back some kind of numeric representation of a function. And now we generate the same x and y range, but with 101 very small steps. And we can then evaluate the spline over that much finer mesh. We now have, instead of 6 by 7, we have 101 by 101. And if we pass that back to R, we can see how it's, this kind of thing is not easy to do, and NAG does it very, very fast and very, very well. So that's the NAG library, I think. 10 minutes to go. One more interface. So KX, many of you have probably heard of. So this is an interface to Q, which is the sort of more SQL-like front end to K, which is, this is their web page, very, very widely used on Wall Street, very high performance, inverted, so columnar database implemented in K, which is a very close cousin of APL. But sort of a reduced instruction set APL is how I think of it, really optimized at working on these, and has this built-in column store. And I think there are some, if we looked at the Cosmos application, for example, which is trying to analyze very, very large volumes of data, depending on what kind of analysis you're doing, there may be cases where if you have humongous quantities of data, using KDB as a database engine might be an idea, at least worth evaluating. You can get a free copy of K to experiment with. It does cost serious money if you decide to end up using it. So what we've built there is similar to what we saw for the R interface, something that allows you to execute Q statements from APL and, of course, convert the Q data structures to similar APL arrays. In this case, that's very easy because it's an array language. It maps very, very closely. And for anybody who's technically oriented, we're using what they call the QIPC interface, which is a socket interface. So let's take a quick look at that. You still have to do a little bit of typing, even though you're using this demo system. So there's a workspace called QConnect. We already have boxing on. And this is really just to, yeah, I've got wrap on in this session. Rows off. Was cut. Yeah. So this is another version 14 thing you can get it to. If you have a very large table being output, you can have it display some of it and then just put ... to show that there was much more there. So this is really to impress Gianfranco a little bit. So I have a table of unit tests here. I'm not using his framework, but I have a unit test table where I have a bunch of Q expressions, and then I have the corresponding APL expression saying what should I get back from Q when I execute this expression. And I think the ones at the top it's fair to call unit tests. The one at the bottom, I guess you can argue about. I end up doing complete select statements, so I'm getting all kinds of data types back. So is that a unit test, or is that a system test, or? Okay, well, we'll have that argument a bit later today. Okay, so I can run the unit test, and at least it lives up to the speed requirement, right? It takes less than 1/10 of a second to run all of those. And what's actually happening inside this unit test thing is I make a connection to Q, which is running this DOS window down here, or as I still think of it, is Q database server running. And oh, isn't that amazing? You don't even have to use the C in K. I can do iota 10 in index origin 0, and I'll turn the folding back on again, and I'll select, I think, 1,000 rows of data or something. Okay. So there's a bunch of different data types here. How that was actually, so the time that it took to do that was actually mostly in the cut user command. You see, if I do repeat this, it doesn't take noticeable time. Those are 1,000 rows of data. And what we've actually converted that to at the moment, I mean, this is something this is very experimental. And we'll need to talk to people about what are the most useful internal representations. I don't think this is it. This looks better in a demo. So having a date converted into a 3-element quad TS style vector is probably not what you want. So this is, it's an experiment that we're making available for any of our customers who think they might really need very high volumes of data. And if anybody starts looking at this and says, well, the interface is slowing it down too much, we'd like a different representation, we can discuss that. We have good help from, we're close relation with the KDB folks, so we can do work on both sides to enable this if it's necessary. So, as I said, Ronald was the man behind the RConnect implementation. We've had help from Sasha, I hope I have spelt his name correctly, at the University of Obninsk, who's a real expert user of R. So he's helped us write part of the documentation and understand really how to use R. And Fiona now taking over responsibility and driving the project to completion, I hope. Jeff did the work on the quad NA callbacks that enabled the NAG interface. And with the KDB stuff, we've had help both from Chris Burke, who wears 2 hats. He's both at KX and he's also a member of the J software team. And he had built an interface from J to KDB, and it was very useful at Iverson College this year to sit down with him for a couple of hours and hear how he'd done that. And Simon at KX. And Gilgamesh actually chipped in a couple of days ago to do some of the Q data type conversions. There's about 20 different data types we get back, and he helped fill in the gaps on that. And I've already done the demos, so that means there are 3 minutes for questions. So RConnect is the only one where we're saying, well, this is an official product, we have a release date. The others are really experimental. Let us know if you'd like to play with NAG or Q. And we'll let you have the software as is. It's all written in APL at the moment. And you can play with it. 3 minutes for questions. My goodness. Gianfranco.
Yes, will all of this work with Linux and through RIDE if you open a window from R, etc.?
Yes. All of it. My goodness. I think so. If it doesn't work, it's a bug. Let us know. We'll fix it. Jeff does all of his work initially under Linux, so the NAG stuff has been prototyped under Linux for sure. Yeah. Paul?
Does the Q, can you bring back a table inverted without, blowing up your workspace by nesting?
Well, that's one of the things you would probably want to change. At the moment, it verts it, and of course, that's grossly inefficient. So if you were to use this in anger, you would want a version that didn't do that. Yeah, but I mean, for a demo, you want it verted. Yeah. Good point. Okay. Thank you very much.